From scanning text to understanding invoices, computer vision is revolutionizing the way we handle data. Computer vision is like giving your computer eyes. It started with simple OCR, optical character recognition, reading printed text. But now it's way more advanced. So what exactly is computer vision and how is it different from legacy OCR? Computer vision, CV, is a field of artificial intelligence, AI, that enables machines to interpret and analyze visual data, such as images and videos, in a way that mimics human vision. It uses deep learning, neural networks, and advanced pattern recognition to understand and extract meaningful information from images or scanned documents. Legacy optical character recognition, OCR, is a rule-based technology that extracts text from images or scanned documents. It relies on predefined templates and structured document formats, making it less flexible for handling variations in layouts. Computer vision, on the other hand, goes beyond simple text extraction. It uses AI-driven models to understand document structures, recognize handwriting, classify data, and even extract context from different invoice layouts dynamically. So, how exactly does computer vision read data from invoices and generate outputs for further processing? Computer vision, CV, in invoice processing involves deep learning models, particularly convolutional neural networks, CNNs, to extract structured data from scanned invoices. The process involves several steps, from image pre-processing to structured output generation. Let's now understand each step in detail. First is image processing and feature extraction. In this, before an invoice can be processed, the system prepares the image using the following techniques: grayscale conversion, which means converting the colored image into a single-channel black and white representation. Binarization, also called thresholding, enhances contrast between text and background by converting pixel values to 0, black, or 255, white. Edge detection, using canny and Sobel filters, helps detect lines, boxes, and text regions. Skew correction and alignment rotates images to correct misalignment using algorithms like Who transform. Why pre-processing is needed? It helps ensure that the invoice text is clean and structured for feature extraction in the neural network. The second step in the overall process is deep neural network, DNN, for text and structure extraction. In this, a CNN-based deep learning model is used to recognize and extract text fields. Here's how it works. Part 1. Image feature detection using CNN layers. A convolutional neural network, CNN, is built with multiple layers. Convolution layers detect small patterns like edges, curves, and characters. Pooling layers reduces dimensionality while preserving important features. Fully connected layers processes extracted features for classification and text detection. Example: detecting the invoice number. The first convolutional layers detect edges of text characters. Deeper layers learn shapes, fonts, and numbers. The final layers classify whether the detected text belongs to the invoice number field. Part 2. Optical character recognition, OCR, using recurrent neural networks, RNNs. After text regions are detected, a recurrent neural network, RNN, like LSTM, long short-term memory, is used for character recognition. This helps in sequentially reading text from detected regions. Unlike basic OCR, deep learning-based OCR can recognize different fonts, handwriting, and layouts. The third step in the overall process is how color, darkness, and backpropagation work in training the model. Color darkness, pixel intensity, is an important parameter for use in feature learning. Each pixel in an image has an intensity, 0 for black, 255 for white in grayscale. The CNN learns patterns based on pixel intensity changes, gradients. Darker regions, text, have lower pixel values, while lighter areas, background, have higher values. The model assigns weights to these pixels to differentiate text from background. Example: invoice number 123,456 inches appears as dark pixels against a light background. The CNN detects these variations and classifies them as text. Next, within step 3 is backpropagation and model training. Once the CNN detects features, backpropagation helps in refining accuracy. Forward propagation, the input, invoice image, passes through layers of the neural network to predict the output, extracted text. Error calculation, loss function, cross-entropy loss. The difference between predicted text and actual text is computed. Backpropagation and weight update. The gradient descent algorithm adjusts the weights of neurons. Weights in the earlier layers are updated based on errors in later layers. This helps the model improve over multiple training iterations. Result: the model learns how to identify invoice fields more accurately over time. The fourth step in the overall process is generating structured output for processing. Once the text is extracted, AI models use natural language processing, NLP, to classify the text into structured data. For example, the output in a JSON or Excel table would consist of different field names and extracted values. Like invoice no is 123456, date is February 29th, 2025, vendor name is ABC Limited, total amount is 50,000. The final output is then structured data, which is then sent to an ERP system or accounts payable software for further payment processing. In conclusion, if we are to summarize that how computer vision AI works in OCR, we can say that, first, it recognizes text and structure. CNN detects key fields like invoice number, date, and vendor name. Then it understands context. NLP classifies the text into meaningful fields. Then it improves via learning. Backpropagation refines accuracy over multiple invoices, and then converts unstructured invoices into structured formats like JSON, XML, or Excel. So this is how computer vision goes beyond simple OCR by learning from invoice patterns, handling different formats dynamically, and integrating with AI-driven processing pipelines. This makes it a game changer for finance teams aiming for end-to-end automation in vendor invoice processing. Imagine you've got a stack of invoices. Instead of manually sorting and entering data, computer vision scans and categorizes everything for you. It extracts key details like dates, amounts, and vendor names. Then it integrates all that info directly into SAP's FICO modules. Boom! Your accounting just got a turbo boost. So, how do you get started? Implementing computer vision is easier than you think. With tools like SAP's intelligent technologies, you can automate invoice processing in no time. Less manual work, fewer errors, and faster processing. Pretty cool, right? That's the power of computer vision in action. Ready to transform your invoices with SAP? Let's make data entry a thing of the past.